Hey guys, Brad here again. So the second edition of the interface board rebuild. Told you we're going to wash down the boards in some Simple Green, and then we're going to bake them in the oven a little bit to dry them out real well. So I'll show you the process for that. So you guys saw the last video where we tore down one of these interface boards, removed the capacitor and ribbon cable. I told you I'd come back and remove all the labels, which I did. And again, all these are numbered, little tie wrap and number on them. I've also gone through and cleaned all the Molex with some double 4 ultrafine steel wool, cleaned them up. And I do have these headers, and I'll replace them if any are bad. But these ones, like again, there's no current flow, so they very rarely are not recoverable. Sometimes when people pull them off, they bend the pins, and I've got some pliers, kind of like a needle nose, but they don't have any knurling in the teeth, so they're just smooth, so you can tweak them back in and adjust them and get them all lined up real nice. So I've got, let's see here, this one is these are both Defender, another Defender. These are all Defender here. I do have a bunch of other Stargate, the other ones for higher inputs. And then I've got, here's another one. This is a Rev B Stargate, Jawless, whatever board will run. This one will run with, and then this is a Defender board. And again, I replaced the battery holders on these. Typically, most of them are pretty corroded. I pull all the electrolytics off the board here. I replaced I pulled the CMOS off and put a nice gold high-end socket on it. Straighten all the pins, steel wool these, remove all the RAM. Video decoders, micro, pull off, straighten all the transistors on the board. I go through and inspect the back, fix any solder joints, clean everything up on them. So these are pretty much, once I wash these, excuse me, they'll be propagated with parts again and then powered up and tried. This board here, actually, I changed the 40-pin header, was busted on it. It was still, you could still plug it in, but the plastic was broken. It kind of bugged me, and I've got the NOS connectors. Also on this one, a lot of the transistors were bent really bad, and I actually replaced all of them, and I dropped them down real low to the board so they can't bend again. Most of them are NPN. I think there's these 3 over here and 1 over here are PNP. A 401 and a 403. Those are the 2 numbers on that. So this board is gorgeous. This thing is really good condition. This is the original battery holder. It looks like it's never been powered up. So anyway, I'm going to clean these up. For the sake of the video, I'm just going to show you the interface boards, and also I had bought a bunch of EEPROMs, you know, for the ROM boards and sound cards and that kind of stuff. And a couple of them had some corrosion on the pins when I bought them, and you know, I've used a real soft stainless steel brush, but I actually bought a Vapor Rust, some of these Goddard silver dip, and a Haggerty flatware silver dip. Anyway, I'm going to do a little video, 10-minute video probably, where I'll put a couple brand new ICs that have a little corrosion on the legs into the dip, and I'm going to put a couple ICs that basically I scrapped because I thought that they were beyond repair, and we'll see what it does. With the labels on it, I might question that, but most of them are just bare ICs, so I'll put them in, take a look at them, rinse them off in water, dry them out, and see how it works. So it's another video. I think, you get a lot of people sanding them and trying to scrape them with razors or use wire brushes, and again, you're taking that plating off. So if we can use a chemical like that just to remove the corrosion off the plating, I think that would really be the way to go. So anyway, first thing I do, we've got the Simple Green here in a spritz bottle. Got a couple different brushes I use. This is kind of a soft, brush used for cleaning tile or grout. And this one works real good for these Molex. It gets way down in these back grooves where you get some crud that builds up in there, and gets in the deeper spots. And then I've got a little coarser brush here, just a little plastic hobby brush. Gets in between these resistors well, and worst comes to worst, you get the old toothbrush. So typically what I do is I'll spritz down the back of the boards, set them in the sink here, and then I'll spray the top side of the board. Excuse me. So they're just soaking in the Simple Green. And I'll do a couple more here just because I've got them. Actually, what I'm going to do right now is turn the oven on. I'm going to put it on warm, and I do have a thermostat in there, and it tells me the temperature on this. So I typically set it for right around 180, 190, something like that. And again, this is just to, when we're done rinsing them off here, I'll show you what I do. It's just to get the water to come off quicker and you know, prevents any corrosion, anything like that. So they're going to be wet for a very limited amount of time. Yeah, I can see the Simple Green, what's dripping off here has got a lot of dirt and dust and grime in it. So yeah, perhaps pay a little more attention to where my hands are when I'm doing this. I tend to want to block the camera view, I think. So we got one more over here. Now I'll pull that first one out I put because it's had the longest soak time. So again, I'll go over the back side of the board, just circular motions here. And again, most of these solder joints, on some of them I went over again. I don't just reflow. Some people call that reflowing. I'll actually go in with solder wick and pull out all the solder, clean them up with the alcohol, and then flow in new solder. And I'd remove all the flux. You guys saw that process, but I still just like to go over it again. And any flux residue, sometimes you get a tiny bit of that sticky tar or from the rosin. Oop, it sounds like the oven's already at temperature. And then again, getting in on these Molex. Just gets way in there, cleans real well. I get in here on the resistors. And again, I'm letting the brush do the work. I'm not, you know, putting a ton of pressure or anything in there. Get on either side of that PIA real good. I tend not to put too much pressure on the header for the ribbon cable just because, and again, this is the same process on all the boards. I do this on every board I recondition. And it makes a huge difference. You'd be amazed. I mean, just trying to clean them with alcohol, or you know, use a soft paintbrush to get the dust off, and then you want to wipe them down. Doesn't compare with the Simple Green. This stuff really gets down to the original solder mask, and then the I think of the name of it here, the green layer on it, the silkscreen mask, I think they call it. I usually get along the edge of this 40 pin pretty good. You get a lot of dust. You have to remember which way these are sitting in the game. Most of the dust and things tends to settle from the top down. So that one's good. Then we'll rinse, usually in hot water. Let that run for a minute. Actually, what I'm going to do is transition these boards over to this sink, this side of the sink. I'll show you why here. Then what I do, in my faucet here, I actually put in a reverse osmosis system in the basement. And I check this water with the TDS, a total dissolved solids meter, and it's sitting at 000 all the time. So what I'll do is put on that RO, and I rinse the board in the RO. And you might ask why I do that. I'm on municipal or city water where I live here, but it still has, it comes out of a well at some point. It still has a lot of calcium, magnesium in them, and those are all conductive materials. And if you just use regular tap water and then it dries on there, you could end up with an issue. Most of these TTL are pretty robust. The chance of it having an issue is pretty low, I think. But so that's been rinsed in the RO water. So then what I do is just put this on the rack of the oven at 180, 190 degrees, and probably a half hour till it's dry or golden brown, whichever comes first. So next step, when these are done, the next video, I'll be putting the ribbon cable back on, soldering the new cap, and then we'll put it in a working system on the bench and test out all the button functionality. And if we find a problem, I'll take you through the troubleshooting steps. And I'm hoping out of these 6 boards, we'll have one that doesn't work. Usually it's the case. The last batch I bought, every one of them had a bad PIA. I might have mentioned that. So we'll go through them. Again, I check them on the system first. If they don't work, I pull them off and start discreetly checking each one of the ICs on here. I'll check all of these are 1,000 ohm resistors that are in series with the input, and then on this end you've got a 4.7K network resistor that keeps them all pulled high, and then they have a capacitor as well. Most of this is for ESD reasons. Run through the buffers, through these muxers to the PIA, and these, I think this might be the one I replaced the 0 ohm resistors on, and then I had to add a resistor. One of these I did. So anyway, next video, that's a step. We'll see you then. Bye-bye.